Mipmap. Mipmapping is a technique to remedy the issue we saw in the previous video. What it does is it pre-calculates the scaled down copies of the texture for fast and more accurate sampling. For example, if we have this 8x8 texture that we saw before that had this issue that if we downscale it to a 2x2 result, then we got a white image because the sample points happen to be in the middle of these white texels. So with Mipmaps we pre-generate a scaled down version of this texture, so a 4x4 Mipmap, and then a 2x2 Mipmap, and then a 1x1 Mipmap. And currently it happens that those are all dark gray. So if we were to now downscale this texture to a 2x2 result, then we could just take this 2x2 Mipmap and sample the dark gray values from here. There is one small problem. So what if we have a texture that is 10x10? The first Mipmap would be the image itself, it's 10x10. And the second one we take half the size, would be 5x5. And then we have 2.5 times 2.5. So this is a problem. How can we have like half a pixel? So the last Mipmap we could create is this 5x5, which still results in a problem where at some point we cannot downscale the smaller versions. The remedy to this is to use power of 2 textures. So this is why in different libraries or game engines it is required for you to have your texture resolution as a power of 2, so that you can always downscale by half up to 1x1 Mipmap. So let's say we now have Mipmaps 8x8, 4x4, 2x2 and 1x1. And we want to show our texture on a 5x5 area. The question becomes what Mipmap we want to sample. Should we sample the 4x4 one, maybe the 8x8 one? Is there some smart way to do this? And it turns out there is. So we have our 8x8 big Mipmap, we have our 4x4 smaller Mipmap, and we want our result to have this 5x5 resolution. And we can see that in this 5x5 resolution, we can actually still keep some of the pattern that is in the original image. If we were to just sample from the lower 4x4 Mipmap, then we wouldn't be able to get this pattern because on the 4x4 Mipmap, it's already all uniformly gray. So we can use both the smaller and larger Mipmap to sample from. For example, this point here, the sample from the lower Mipmap would be from here, and from the larger Mipmap would be from here. We can then use bilinear interpolation on both of those to find the actual values, and then we can take those values and combine them in a smart way. So this 5x5 result that we want is more closer to the 4x4 Mipmap than it is to the 8x8 Mipmap. So we can interpolate between those two values, the one from the larger Mipmap, the white texel, and the one from the smaller Mipmap, the gray texel, and calculate this light gray value that is now in the result. This kind of sampling from both of the Mipmaps and then interpolating between the results is called trilinear filtering. Because what we're doing is bilinear filtering on the lower Mipmap and bilinear filtering on the larger Mipmap, and then one more linear interpolation among the results. So there are also other options to configure this minification filter. For example, we could sample from the nearest Mipmap. That would result on us sampling only from the 4x4 Mipmap if we want to get a 5x5 result. We could also specify should we use the nearest neighbor interpolation or bilinear interpolation on the Mipmap that we sample from. If you use the linear interpolation on the Mipmaps and then linearly interpolate between those two results, then that's this trilinear interpolation. From this video, you should now understand Mipmapping. How and why is it useful? So it's useful because we can quickly sample the values from a Mipmap without having to do too many samples on the larger image. It also allows us to keep some of the pattern from the original image while it's still possible to show it. You should also understand why you should use the power of 2 textures and the different texture sampling schemes that use Mipmaps.